So now let's talk about the range of any trigonometric function that has been given to you. So let's say if you have any trigonometric function in this format, a sine theta plus b cos theta. So its maximum value would be root under a square plus b square, and its minimum value would be minus root under a square plus b square. So this is my minimum value and this is my maximum value. Now based on this, if any type of equation has been provided to you, as we studied in functions, you simply have to add, divide, subtract or multiply, or whatever operations you need to complete to make that exact function you can do, but keeping in mind this range for a sine theta plus b cos theta. So again, a very simple way to remember the range. Now the other thing is, let's say what if in a question you are given a quadratic trigonometric function, then how are you going to find out the range for that? Let's say I have a quadratic trigonometric function. Let's say, let me take an example. Let's say I have sine square x plus 16 sine x plus 2. Now let's say if I have been asked to find out the range of this quadratic equation. So what is the first step that I'm going to take? I'm going to convert this into a perfect square. So if I have a perfect square, in my perfect square I'm going to have a single power of x. I mean for sine x, my highest degree for that would be 1, and for sine x I know its range ranges from -1 to 1. Based on that I can again use my other operations to form this equation only. So let me show it to you. How can I write this in a perfect square form? So can I write it as sine x plus 8 whole square? So this would become sine square x plus I would have 16x plus I would have a 64 as well. So I have a 64 additional here and I have a plus 2 outside. So I'll subtract 62 from here. Then if you look at this equation now, this can be transformed into this if I open it up. So now that I've gotten this equation, I know that my sine x ranges from plus 1 to minus 1. So I can write it as sine x plus 8 less than equals to, here I would have 9 and here I would have a 7. And now if I square it up, sine x plus 8 whole square minus 62. So this would become 9 9s are 81 minus 62. And here I would have 49 minus 62. So this would be basically my range for this entire function. So this is how you find out the range for any quadratic trigonometric function that has been given to you. Let's look at this question. For example, the maximum value of 3 cos theta plus 5 sin theta plus 5 sin theta minus pi by 6 for any real value theta. So we need to find out only the maximum value of this. So first of all, we can see we have sine of alpha minus beta. So let us open it up and then let's see what are we getting. So from here we would have 3 cos theta plus 5 sin theta plus 5 times of, here we would have sin theta cos pi by 6 minus cos theta sin pi by 6. So now let me open this bracket up completely. So here I would have 5 sin theta plus, now cos pi by 6, which is cos 30. So cos 30 is root 3 by 2. So I would have 5 root 3 by 2 sin theta minus, and here sin pi by 6. Sin pi by 6 is 1 by 2. So I would have 5 by 2 cos theta. So basically what does this transform into? So this would become 1 by 2 cos theta plus, here I would have sin theta 5 plus 5 root 3 by 2. So this is what I am going to have. Now what would be the maximum value of this? So simply the maximum value would be root under a square plus b square, which is nothing in this equation but 1 by 4 plus 5 plus 5 root 3 by 4 whole square. So I've already squared the 2 below so that I can get 4 here. So here Upon solving this function, I would have a 4 below, again under root, and what would I have ultimately? This would become 1 plus, this would be 25 plus 75 plus 5 5s are 25, 50 root 3. And what would this transform into? This would become 100, 101 plus 50 root 3 by 4 root under. So this is going to be my maximum value. So this is how you find out the value which has been asked to you in the question. Now let's talk about trigonometric series. Now again, let's say if any trigonometric function has been given to you in a series format, which is in either sine of a plus sine of a plus d, sine of a plus 2d, cos of a plus d, cos of a plus 2d, in either of these two formats, then simply you can write down your answer as sine of nd by 2, sine of d by 2 into sine of a plus n minus 1 d by 2. So the only difference in these two answers is that when you have a cos series, you would have a cos function, and in your sine series, you're going to have a sine function. And one more series that you need to remember is this multiplicative series of cos. So cos theta into cos 2 theta into cos 2 square theta up till cos 2n minus 1. So remember this thing, you have it up till cos of 2n minus 1, because here when you had cos theta, it was actually cos of 2 to the power 0 theta. So this is how you came up to this. And this is equals to sine of 2 to the power n theta by 2 to the power n sine theta. Now let us look at this example. If you look at this example carefully, you can see that it is this series. Basically, theta here is pi by 33. And you can see that it goes up till 2 to the power 4, which means 2 to the power n minus 1. So 2 to the power n minus 1 is 16 here. That means my n minus 1 would be equal to 4 and my n becomes equals to 5. So this is what my values are for this basic series. So now if I try to multiply all this, what am I going to get? Sine of 2 to the power 5 theta, and what was there in the formula? 2 to the power n sine theta. So from here we would get 2 to the power 5 sine theta. So if I replace theta by pi by 33, so this would become 96 times of sine of 32 pi by 33 upon, this would become 32 times of sine theta, sine pi by 33. Now if you look at 32 by 33, you can write it down as pi minus pi by 33. So now I'll write it down as 96 by 32 into sine of pi minus pi by 33 divided by sine of pi by 33. Now if I take this here, what would it become? So 96 by 32, it is basically 3. So from here I would get sine of pi by 33 upon sine of pi by 33. Since it is pi minus pi by 33, that means it lies in the second quadrant, and in my second quadrant my sign is always positive. So this would simply just cancel out and we would get 3 as our answer. So this is how you generally solve questions which are related to series and ranges. Now one thing about range that I missed out, I forgot to tell you. What if, let's say, in any type of equations you are given sine to the power n theta, let's say, or cos to the power n theta. What would you do then? Simply your motive would be to write down your equation as y is equals to f of x, then find out your dy by dx, which would be f dash x and then you try to find out your maxima and minima. Now if maxima and minima, you haven't learned much about maxima and minima, then of course you're going to be learning it when we study application of derivatives. Then here I'm just telling you this portion here, that if you need to find out your a range of any trigonometric function which is of this format, sine to the power n theta or cos to the power n theta, or be it any other trigonometric function to the power n theta, for that you simply find out your dy by dx, check for maxima and minima in the range or in the domain they are defined in. Now talking about the domain and range of our functions. So sine x, whatever value you can put inside the x-axis, you're going to get value ranging from -1 to 1, and its periodicity is 2 pi. As we had studied in functions, the periodicity of sine x is of course 2 pi, because after 2 pi the function starts repeating itself. For cos x also it is the same thing. For tan x, the domain is going to be R. The only difference is that since we have a cos x in the denominator, so we have to remove all those cases in which cos x can be 0. So when do we get cos x as 0? We get cos x 0 at pi by 2, at 3 pi by 2. So basically we are getting cos x to be 0 at n pi by 2. So that is why we remove r minus 2n plus 1 pi by 2. Now this is the way of writing it, our pi by 2's multiple. So this is how we write it down. Our range is going to be r, because tan x can vary from minus infinity to plus infinity. So it is r, and periodicity is pi. After pi it starts repeating itself. We'll take a look at the graphs as well of all these functions, so that it gives you a more clearer understanding of domain, range and periodicity. For cot x, again the same thing. It is going to be r, but we have to remove all those cases in which sine x can be 0, and sine x can be 0 when we have theta is equals to n pi. So we've removed those portions and we get r, and pi is our periodicity. For sec x, since it is 1 by cos x, so all those portions are removed where cos x can be 0, and its range is from minus infinity to minus 1, union 1 to infinity. For cosec x, again it is r minus n pi. So now when we look at the range of cosec x, it is written as r minus -1 to 1. So how can this be written as? This can also be written as minus infinity. Sorry, here this would be a closed bracket, open bracket. But of course minus infinity or infinity, you cannot put it inside closed bracket. So keep this thing in mind. So this would be minus infinity to minus 1, union 1 to infinity. So this is the exact same range that we would get for both sec x and cosec x. Now this is the other way of writing it down, because we are not including the values which are coming from -1 to 1, excluding those values. We are including that in our answer, right? So we have to exclude them. So that is why we can write it down as r minus -1 to 1. Let's look at this question. Let S be the set of alpha belongs to R such that the equation this has a solution. So this equation, since it has a solution, first what are we going to do? We see we have a cos 2x, we have a sin x. So simply let us convert this cos 2x into sin x, and then let's see what are the equation, or what is the type of equation we are getting. So cos 2x can be written as 1 minus 2 sin square x. So this would become 1 minus 2 sin square x plus alpha sin x is equals to 2 alpha minus 7. So from here we get 2 sin square x minus alpha sin x plus 2 alpha minus 8. So this is equals to 0. So this is the equation that we are getting. Now from this equation, of course, it would be difficult for us to combine this into a perfect square and then solve our answer, because we do not know what our value of alpha is, right? So what we'll do is we'll simply try to find out the value of sin x using our quadratic equation. So this is a quadratic equation in sin x. So my sin x would be equal to minus b plus minus root under b square minus 4ac, 4a into c, 2 alpha minus 8 upon 2a. So this becomes 4. So here we would have alpha plus minus root under, this would become alpha square minus 4 2s are 8, 8 2s are 16 alpha plus 4 2s are 8, 8 8 is 64 upon 4. Now if you look at this value inside the square root carefully, what is it? It can be written as alpha minus 4 whole square. Sorry, it can be written as alpha minus 8 whole square. So if I write it down as alpha minus 8 whole square, so this would become alpha plus minus root under alpha minus 8 whole square divided by 4. So this would simply become alpha plus minus alpha minus 8 upon 4. Now if I try to make two cases, so what would be my first case? My case 1, where I've taken, let's say, plus, so it would become 2 alpha minus 8, so it would become alpha minus 4 by 2. And what would be my second case? When I take the negative sign, so alpha and alpha would be cancelled out and I would have minus 2. So basically my sine x is either alpha minus 4 by 2 or it is minus 2. Of course, minus 2 is not possible because sine x ranges from minus 1 to 1. So this cannot be possible. So my sine x is basically alpha minus 4 by 2. Now what is asked to us in the question? Let S be the set of alpha such that this has a solution. So S is equals to. So basically we need to find out our set for alpha. Now we know that our sine x ranges from minus 1 to 1. That means my alpha minus 4 by 2 would also range from minus 1 to 1. So this is exactly what we are getting from here. What would my alpha range from? This would become 6 here. And here I would have minus 2 plus 4. So this would become 2. So basically my S set is 2 to 6. We're including both. So S is basically alpha belongs to 2 to 6. So this is my answer. So this is how you solve again. Here we did not use that perfect square format that I had taught you because here we had alpha in place of sine x. Of course, if I have the coefficient as alpha, I do not know what is that going to be, right? We cannot find out the exact numerical value that it is going to be. So that is why we used this method to solve this question. Now talking about the graphical representation. Of course, you've already known all these graphs earlier. So when we talk about sine x, it ranges from minus 1 to 1 and it has a period of 2 pi. So that is why you can see it starts repeating itself after 2 pi area. And its domain is R. Same for cos x. The only difference is that at 0 value, I have my output as 1. However, in sine x, at 0 value, I had my output as 1 also. For tan x, my period used to be pi. So you can see from minus pi to pi, my function is same and it starts repeating itself again and again. And if you look at the range, of course, this graph extends up till infinity and this one goes up till minus infinity. So we have our range as R as well. Cosec x again, this would simply be the reciprocal of sine x. So that is why whatever graph we had of sine x, it would simply be reversed for each and every intervals at parts. So again, this starts repeating itself after 2 pi. So its period is 2 pi. Sec x again, the reversal of cos x, and tan x, the reversal of cot x. So this is how you generally represent graphs. Again, it is recommended that you remember all these graphs so that whenever you need to find out range or domain or let's say periodicity of any type of function given to you, you can solve it using these graphs. And these graphs would help you understand the values that sine x, cos x, tan x and all these other functions generally carry and what they output gives.